to be present. I know it's going to be a very interesting seminar. For those of you who were not here in our first seminar of the Monieson Ideas series, this is modeled on the Boston Ideas, or the Ideas Boston Northeastern Seminar concept, which sparks innovation by bringing together people from multiple disciplines and by bringing together people from the academy and the community. So by bringing conversations into existence that might not otherwise exist, we hope to spur either new projects or new collaborations. We also hope to inform you in ways that you find interesting. I want to thank our representative from Palo CFTC, the Prince Edward Lennox Addington Community Futures Development Corporation, is co-sponsoring this event. We're very grateful for their sponsorship. Each of you should have received your package with speaker bios. Just to save time, because we ran out of time in our first seminar, I'm not going to introduce each of our speakers. I'm simply going to point them out. And in your packages, you should have their bios. Brian, would you just raise your hand? Brian Burt of Burt Greenhouses, Professor David Mody of the Department of Chemical Engineering, Andrew Pollard, Dr. Pollard, in Queen's Sustainable Bioeconomy Center. He directs the center. Stephen Sottile, so that's Utilities Kingston and Switch, and many of you know Professor Stephen Moore here at the School of Business. I thank you all for coming, and I'd like to invite Brian to start our session. You'll note that Andrew in our center has a little 5-minute timer that will try to keep our speakers on track. It should be fun.
You don't, I do.
So some of you people may know us. I'm Brian Burt from Burt's Greenhouses. We run a small greenhouse just west of Kingston. We're about 90,000 square feet of total space, heated both inside and outside. That's probably a tenth of what is a normal sized greenhouse down in southwestern Ontario. So we're on the small end of the scale for greenhouses in Ontario. Not that there aren't lots of other greenhouses that are our size, but most of the production is coming from much larger operations, and that it has an effect on the scale of installation for a unit like we use to heat our greenhouses. In 2005, we decided to install a biomass heating system. We started 2005. Our first heating season was 2006. We have heated ever since that time. So what I'm supposed to be talking about today is challenges and opportunities for biomass heating that we're using. And there's the first challenge is fuel quality. We've bought fuel from a number of different sources, and each of these sources is not fully concentrating on the production of fuel. They're concentrating on trying to get rid of a waste stream off. So we're using construction demolition waste, the wood stream part of that. We've had a fair amount of difficulty getting them focused on getting this kind of stuff out of the stream. Issues are maximum particle size. If we get too large a pieces, then we can cause blockages of our augers or airlocks, that sort of thing. Fines are also an issue. It affects the combustion characteristics once it goes into the combustion chamber. And moisture content is obviously an issue because you're paying for moisture and also makes the whole process much more efficient. So that's a huge issue for us. It's been very difficult for us to deal with suppliers. We continue to try to, because the people who are operating machines, the people who are purchasing machines, they don't necessarily know how to operate them to meet what standards we are setting. And they oftentimes don't listen to us. We try to get them to listen to us. We've had some good success. Our first supplier was in Belleville, and he started out great, sort of started slipping. We went back and started working with him, and the more we worked with him, the better it got. He's out of business now. So, you know, we still struggle with this, but, and I, what solution is that? The next challenge is that of operations and installation capacity. These systems are relatively new, so if I were to purchase a natural gas system, it wouldn't be very difficult for me to find a local supplier that would be able to put a natural gas system in, and I would be way the races. It wouldn't be a problem for us. With a system like this, I've got to go much further afield. We went to Manitoba and purchased a system, so we were pretty much on our own. The training was 30 minutes. We had the owner of this company come and he spent 30 minutes with us with the control panel, explaining to us how the control panel worked, which was probably fine because the control panel didn't really work, so we had to do a lot of things ourselves. So this is just a bit of an indication of some of the things that we had to change with this system as it came from the manufacturer. Other things are, we went through a troubleshooting process where our grate, this is a movable grate system, and the grate was stalling. So we had to find out why this grate was stalling. At first I thought it was nails, and the other thing here is that the person that's getting up in the middle of the night is me. So it's me going out there at 2 in the morning with this stalled grate, trying to get it going, trying to make sure we can keep it operating so we're not having to burn oil as backup. And went through a week of this, and finally, by chance, discovered that our oil was overheating. This was a hydraulic motor system, and the lines for the oil were running underneath the combustion chamber. It was a wonderful design. And so as we operated this system harder and harder, it started to heat more, and that's when we started running into problems, and the oil just became too thin. It thinned out, we couldn't run the motor. That's what was stalling it. Okay, and so that's kind of the summary of what are some of the problems that I see with this type of technology. There needs to be fuel standards. I'm not sure exactly how we can establish those fuel standards, but if we could, it would make our life an awful lot easier. And there needs to be capacity that's built within the community, both for installation and operation of these units, because there aren't very many people that you can go to and find information. We've been around and spoken to a lot of other growers, and some people have phoned us about the particular unit we've got in order to get advice, but there's not that much out there, and that capacity really needs to be built. Okay.
We're only 30 seconds over.
Well, it's a race.
Engineer will
No
win.
pressure.
Can I get you back on track? That's the big question though. I'm going to speak very quickly. Good afternoon, ladies and gentlemen. My name is Mody, and my claim to fame is not really much of a claim to fame at all. I look after a course in chemical engineering called TEAM, and through that course, I see one of my graduates here. I've been exposed to many opportunities to observe alternative energy technologies and conventional energy technologies. It's been a really great opportunity to sort of look over the shoulders of the students doing work. And I think when we look at this problem, I think we tend to isolate it a little bit too much. We look at energy as a problem. Because I'm a chemical engineer, I can't really divorce myself from looking at it in terms of a chemical. I look at energy really as being the lowest common denominator in this game. And I would challenge you to look at chemicals as a higher value added, and then the derivation of energy from those as sort of an offshoot. And so I think you've got to pull back and look at biomass and other things as a source of many useful items in addition to energy. And the big question really then is can we transform our energy materials and consumption to a point where sustainable energy meets the demand that we have for energy before fossil fuels run out? When does this need to happen? And does climate change how does climate change play into this? So I wanted to just quickly go through some of the strengths that I see in biomass as an energy. And I kind of throw this out to you guys to see if you agree or disagree with me. and maybe even add to the list as well. I think the big strength, of course, in biomass is that it's a relatively quickly renewable feedstock. So a few years to a few decades type of time frame. There's a wonderful revitalization of the agricultural economy that is going on with biomass. And I think that's a really significant thing that's going on, despite all the criticisms that you hear. I think it's great that we're putting money back into the farms. The other great thing about biomass is that it's scalable to the demand. If we need more energy, more chemicals, we can just basically grow more to a certain extent. If we need less, then we can grow less. The true energy supply to that biomass is, of course, solar energy, and the solar energy has a long enough life that I don't think we really have to worry about that. By the time the sun runs out, we're going to need sweaters and flashlights. And of course, the nice thing about a lot of this is that other valuable materials can be derived simultaneously. And on the whole, I would say that the climate change issues are generally aligned with the alternative energy issues. Not always, but they are generally. So there's some synergy in trying to deal with the two problems there. Let's just talk quickly about weaknesses. The big weakness is really about weather, I would say. Actually, there's quite a few weaknesses. Weather has a really strong influence on the productivity. The temperature, the other issues that come into this temperature, solar insolation, CO2, water requirements, soil quality, and nutrients all have an effect on the productivity that you can achieve. Some of the crops that we're talking about use fertilizer, and of course fertilizer is generally derived from natural gas. So if you look at some of the companies that are producing fertilizer in Alberta, Agrium I think is a good example, they are Alberta's largest user of natural gas. So, you know, it's not a done deal that we're not using fossil fuels. There's some synergy that's going to go on there. One of the big things that we tend to think of, we get kind of roped into thinking all green products are healthy and good for us, and that's not the case. There's lots of toxic green chemicals out there, and you got to be weary of kind of a mindset that everything green is good. There's a lot of issues around converting these materials into energy and chemicals. There's a lot of inefficiencies that go along with these systems. There's inefficiencies in oil and gas as well. But these inefficiencies require us to grow more feedstock or use more fossil fuels. So that's a bit of an issue. Okay, I'm going to zip through this pretty quick then. Some of the opportunities then that are here is that there's a lot of money at stake here. There's huge opportunities in terms of a knowledge economy. There's opportunities for synergy around biorefineries and heat integration. And hopefully there's some opportunities around helping climate change as well. The big threat here, I'll be fast, is the low cost of fossil fuel. The big issue, the big elephant in the room here that people forget about is that natural gas and shale gas is a huge asset, which is completely an opportunity right now. It's very, very competitive, and people are saying that shale gas, natural gas is going to flow from the northern United States into Canada rather than east and west. So natural gas is likely to stay very cheap, and so if we're going to make anything work here, I think you're going to have a synergy between natural gas and biomass. The other big threat, I think, is policy change can change overnight. And disruptive technologies. When something like this comes along, we're going to be in really good shape, but we're a long ways away from it. So I'll leave you as a question at the end here. I believe that energy is an enabler, not an end to itself. And I think the question is, can we create a supply chain of products and lastly energy from fast renewable sources? And how do we do that?
So let's save all the questions till the end.
Steve 1 or Steve 2, again.
The handsome one.
I want reports. Where's that little clicker?
It's right. Oh, there's a clicker, but I've got this.
All right, thanks for having me. I'm a graduate of the Queen's School of Business. It's really fun to come back. The noise outside kind of reminds me of Thursday night, coming home from Alfie's, when my roommate got lucky. Utilities Kingston is a proud member of Switch. I'm going to talk about a little bit about these guys. Any of you in the room who are interested in renewable energy, alternative energy in Kingston, finding a job, talking with some people who know a lot about different aspects, find us on the web, come to one of our open meetings, talk to Melody or Anna Marie that are sitting right there. It's a really good place to learn. What's with the mustache? I feel I must explain it. It is Movember. I promised the guys at our office who are on a Movember team raising money for prostate cancer that if they raised $1,000, I do something ridiculous with my face. They did it in the first week. I said, if they can keep the pace up, if we can keep the pace up, this will stay. We have 2 days left, so if you're interested, go to the Movember site and donate to us, okay? It's a great cause. Why are we even here talking about distributed and sustainable energy? Fossil fuel resources are becoming more expensive, regardless of the talk of natural gas remaining cheap. With energy demand rising in international markets exponentially, there is no doubt that energy is going to be harder to come by and more expensive when you are able to come by in the future. So we're looking to alternatives for those reasons. Environmentally, some of the costs that are not internal to the price of energy are becoming issues, whether it be with political initiatives such as Ontario's decision to eliminate coal because of the adverse health effects and environmental effects it has, or otherwise. Building large-scale generation, so traditional central sources of energy, this is increasingly financially and politically infeasible. Financially infeasible, look at the case of a nuclear reactor where you have a huge capital outlay at the beginning, cost overruns that are likely to occur. Many governments are not willing to back that kind of a technology where they have to spend large sums of money up front to get this kind of generation online. Politically infeasible, even if certain types of energy are affordable, it's getting harder to build this stuff anywhere. Just in the case of Oakville, where a natural gas peaker plant was proposed to be built, and the public opposition that comes up. People are searching for more scalable, affordable, and politically feasible options for generating electricity. This is the point here that I think we have to really get at when talking about energy sources. It's not about how much you produce, it's about how you use the energy you can produce. 1/3 of the capital assets, 1/3 of the system capacity that we have is only used 5% of the time to satisfy peak demand in the summertime in Ontario. That's similar in many other locations in the world. We have to make more effective use of our resources, moving to a system of smaller generators, more widely distributed, that produce when and where energy is needed, is going to help us move down that cost curve. And it's going to prevent us from building stuff that we're not using. Uncertain economic and technological environments require a more flexible energy system. Demand is no longer predictable. In Ontario, it was thought, well, energy demand will likely go up 1 or 2% a year from here till infinity. And our plans were based on that. What you've seen in the last year is a transformation of our economy from a manufacturing economy. The recession, demand has dropped. People were not expecting this. We have a lot of sunk costs. We have a lot of stranded assets if demand starts going down. That's why we need a more flexible system with smaller distributed sources that we can turn on or off, commission quickly or decommission if we don't need it. Energy produced in your community by people you know with sources you're comfortable having in your backyard is awesome. That's the other thing that I think is pushing this question. Let's face it, I'd rather get my juice from solar panels on my neighbor's roof than from a facility that's causing destruction somewhere. The challenges, a centralized system legacy versus a distributed energy future. The standards, the codes, the engineering, all of this stuff is designed with a central grid in mind. We have to fight against that when we're trying to implement bottom-up solutions. There are no more one-size-fits-all solutions. You can't just build a big plant and serve a whole province anymore. Geographically, there are differences in power demand and resource characteristics. I've mentioned long asset life and paybacks. This is long-term planning. How do you make a quick change when you're planning things in a 20 or 25-year time frame? It's very difficult. This one here is important. Energy is a part of all business, but it's not the business. And that's something that everybody has to think about when you go away and you leave business school. It's very difficult to get people who use energy to think about energy if they're in the business of making cars, if they're in the business of selling products. It's integral to their business, but it is not their business. And so getting people to conserve can be difficult. I'm going to go really quickly through this. How do you overcome it? Strong, consistent leadership and persistent and consistent effort. We need folks in our governments and in our businesses who are considering energy in every decision they make. And that's all of our job when we get out to the business community, to make sure that it's part of the decision-making process. Rely on your friends, because no person is going to be able to do this alone. It requires a diverse group of technologies implemented in any different location, depending on the resources available. Build your network. Come and see us at Switch. We're helping each other out to do this in Kingston. Keep your incentives and procurement mechanisms simple. Feed-in tariffs. Simple prescriptive conservation incentives that are tweaked over time with market conditions really work. You have to challenge rules and convention with logic and numbers. And if you do that, if you do the analysis, every time I've done this analysis and sat down with people who maybe didn't have the same opinion, sustainable distributed energy will win every time in the long term, I guarantee you. Focus on the simple stuff. We've done well in our community with our utility company doing these types of things and others. And I am here to help if anybody is interested in learning more. Thank you.
Hi. Yeah, I kind of figured I'd jump in there before that. So I'm Andrew Pollard. I'm in mechanical and materials engineering and also the director of SBC, or the Sustainable Bioeconomy Center. Some of you will have this card there, so go around and look at the center and the web. So, energy alternatives. I'm sort of looking here at the Great Lakes region, simply because it provides us with a focus. And then what I'm going to do is to drill down to look at alternatives for the local region being in just in and around Kingston. So, first things to note is we have something that pops up every time that I give this talk, which is limits to growth. One of the things that I'm not going to talk about today, but if you think about that book, if you have not read it, then one of the big conclusions of that book is there are just too many people. I'm moving on from there, okay? So, what? Okay, all right. Okay. Okay, in 2008, Garneau from Australia put out this statement: climate change is a diabolical policy problem. It's harder than any other issue of high importance that has come before our polity in living memory. And while there may be scaremongers out there, at the end of the day, we are putting too much carbon dioxide and other stuff into the atmosphere, and it's got to go somewhere. We're cutting down forests, so the forest and the agriculture cannot absorb it all. So why is it diabolical? Another word for diabolical is fiendish. It means that we need international collaboration. In other words, if Canada wanted to make a change wholeheartedly on its own, what effect would that have on a worldwide basis? We need agreed upon targets and trajectories. That is, how we're going to get to those targets. We need a policy framework. We've heard about not in my backyard. We just heard the ultimate statement, not in my term of office, or NIPTOism. And of course, global agreement. We need to worry about adaptation and mitigation. We need to recognize that we have an infrastructure on this planet that has been built up over 150 years. All we've done is put holes in the ground, pull stuff out, and everything is where we have it today. The real question now is, how do we move forward? Energy sector transformation. Approximately 90 to 95% of all the fossil fuels used today are used in one form or another for energy. It's not for chemicals, it's for energy. So this is where, in some ways, I disagree with one of my colleagues, David. I think the real important thing here is how do we address the energy issue and transform us from fossil fuels to something else. We have transportation limitations if we start thinking about how we're going to shift stuff around when we don't have fossil fuels as a support basis. And then the other part of it is how do we reconfigure land to be able to handle the needs of an emerging bioeconomy. But with all of this diabolicalism or fiendishism, the big problem is nobody ever mentions don't you dare touch my standard of living. So we need a silver buckshot approach, and so we need to consider wind, and I think we've got a beautiful example out here in the lake. Wind is accounting for approximately 300 to 500 megawatts of energy in the province of Ontario. Solar PV and thermal, which is hot water and electrical. Wave and tidal. We have the Great Lakes, we have the St. Lawrence. If we look at whoops, if we look here, then this is something that's in the Bay of Fundy. It's broken, but that's okay. We're working it out. It's fluid mechanics. Then we need to worry about conservation measures, including smart grids. So you basically have an active grid where you have distributed, as was said, distributed supplies of energy, but then you have distributed control of that and how it is managed locally and in a broader grid-like pattern. Then, of course, there's biomass, and then finally, down at the bottom, if coming back to Dave's idea of a fusion heater or something, then of course we could go to something that comes right out of left field, which of course is coal fusion. If we think about things in terms of regionalism, then there's one small step. If we take one small step here, maybe we can make some changes. So we have what we call a push-pull situation. So if we go back to Brian's comment with respect to what he's doing, he's pulling in the sense that he knows what he wants to do, and he's gone to a supplier to find the material that he needs. It may not be in the exact form that he needs, and so on. But then if you start talking to farmers about, well, I need to supply biomass, and as a result, I need somebody to provide the market for it. The customer base is not developed beyond the niche of home heating, at least at the moment. We have forestry options, yes, I know. Then we have general issues such as biodiversity, food and fuel, emissions, water environment, transportation, infrastructure. And then finally, the adaptation is climate change is occurring, so what decisions are we making today and what will happen in the next 20 years after we've made those decisions. So finally, we have this, and I'll leave that and get off the stage while you read it.
What I want to do, and I'm going to start even before this is ready, because I've got some things to say before we talk about these guys. What I want to do is give you a sense of urgency and also a sense of hope. And here's the sense of urgency first, and it's probably what you don't want to hear. There is frozen methane in the tundra around the Arctic Circle that is equivalent to all the coal reserves on Earth. And we've already increased the temperature of the Arctic 2 degrees. And there are places now where you can go to the Arctic, drive an iron rod in the ground, get down on your hands and knees with a cigarette lighter and light the methane that's coming out of the ground. Methane torches. There are several YouTube videos on this. You can look up burning lakes, you can look up methane torches. The problem with this, of course, is that world governments have committed to climate change solutions which will guarantee a 4 degree C rise in global average temperatures. If we do that, then the Arctic will rise from 10 to 16 degrees, and that tundra will most certainly melt, releasing methane, which is 20 to 25 times worse than CO2 in terms of warming our climate, and we will have runaway climate change that we can do nothing about. Now, the consensus is that we have 10 years, 1 decade, to reduce our carbon emissions by 50 to 80%. But everybody's in denial. Nobody wants to hear this story. Now, how many of you think that we will reduce our CO2 emissions by 50 to 80% in a decade? How many of you think that's going to happen? Now, that is the political question. How many of you think we can do it? How many of you think it's possible? It is absolutely, definitely, clearly doable. There is no question about that. It is not a scientific question. It's a political question. There are very smart guys, much smarter than we are, who have figured this all out. One is Lester Brown. Go to his website. He has detailed plans for how we can, in effect, reduce our carbon emissions by 50 to 80% and avoid this problem. Amory Levin's my favorite geek. I mean, you know he's a smart guy. Look at that hairline. Right, Andrew? I mean, you know, he's a smart guy. You can tell a mile away. He has all kinds of plans as well. So, the first part was the urgency. This part is the hope. But remember, it's not a scientific question. It's not a question of can we do it. It's a question of will we do it. We need two revolutions. We need a revolution in efficiency, and we need a revolution in production. Part of the revolution of efficiency is very simple. For instance, even in the US, if the 40 worst states were as good as the 10 best states, US electricity use would be cut by 1/3. That's massive. Then we can close 62% of all coal-fired US power plants. So it's not hard to do. There is enough wind. If we use 1/5 of the Earth's available wind energy, we have 7 times more electricity than we need. All we have to do is build the turbines. Go to Innowatt Tech Company. They have a really neat piezoelectric system where they're building roads when the cars drive over the roads. That creates energy, enough energy. A mile of this road will have enough energy for 600 homes. There's enough solar thermal resources in the U.S. Southwest to satisfy electricity demand 4 times over. The heat in the upper 6 miles of the Earth's crust is 50,000 times as much energy as in the coal and gas reserves. I mean, it goes on and on. So it's not a scientific question. It's not an engineering question. It's a political question. So, China has doubled its wind power capacity every year for the last 10 years. Or, sorry, the last 5 years. They've doubled it every year for the last 5 years. Think about that. What has Canada done last year? 2.4 gigawatts up from 2. So as long as we have a government that has its snout buried in what has been called the world's biggest man-made ecological disaster in history, otherwise known as the tar sands, it is likely that this country is not going to go in the direction of renewable energy. But really, if you care about the world, that is where we have to go. Thank you.
So we have about 20 minutes for discussion, and we would like you to direct your questions to our panel. They can also use this opportunity to expand on points that were a bit rushed. So with no further ado, you have the floor. We'll start here, please.
I can't remember the gentleman's name from SWAT, Chemical Engineering. Sure, I can't remember which. That's it.
Mody? No, Dr. Mody, Representative Mody.
In your strengths, Dave, we have, you've listed it's a quickly renewable feedstock, but then in your weaknesses you say it could take months or years or decades to grow? Are you talking about the individual items or the system?
The individual biomass. Yeah. So it's fast relative to fossil fuels, but it's slow relative to how fast you would probably like it in many cases.
Can I add to that? That depends upon your decision point. So for example, Lafarge Cement to the west of us is trying to grow biomass on an annual basis to feed their kiln. So it's the type of biomass that they are trying to identify that would be the most suitable. If you wanted to rely on a particular type of tree, for example, then you may be at a 10, 15, 20-year cycle. But collectively, we need to look at a balance between the short growth and the longer growth to be able to feed and displace the fossil fuels. So, for example, with Burt's, they're using construction residue. I try to eliminate the word waste from my vocabulary. So, whereas others can use short rotations.
Can you provide some examples of what those biomass items might be, what those ingredients would be, and how that might, I guess, perhaps use land that might not otherwise be used for, to grow food for people, other agricultural purposes? Like how would you balance out how you grow food as opposed to biomass fuel items in that area? How is that being sorted out?
You go ahead, Andrew.
I think everybody is very, very sensitive to the food for fuel thing. And so everybody that's trying to do this is trying to stay away from that by looking at what they call marginal land. That is land that is not suitable for growing food, but the type that we currently have. And then looking at what is grown and growing it for the food value. And then there's this delicate balance between the residual, stalks and so on, that may be needed for animal bedding, animal fodder, recarbonization of the soil and so on. So there's this delicate balance that needs to be struck. I think we've gone away from the corn for ethanol, I hope. So I know that with Lafarge and I know with Ryan and anybody else is trying to do this, they're very sensitive to the food for fuel. There is hopefully something occurring in Lennox and Addington where farmers are beginning the process of growing biomass that is purpose grown on marginal type lands to the north of here that could be used in a heating situation. I'm not that familiar with it. There are others in the room that are.
I'll add to that just a little bit. I'm from Tamworth, which is north here, right at the edge of the shield, and there are farmers that have, when mad cow disease pretty much wiped out the cattle industry up there, and so there's lots of pasture land, which isn't good for field crops, but is good for either pasture or for marginal land, and farmers are growing switchgrass, which then is harvested with conventional hay equipment and then pelletized to use as a heating fuel. So that's going on right over here.
Switchgrass, are you burning switchgrass yourself, or?
We don't, no.
No.
We burn wood.
I think you're going to see a bit of a free market economy evolve, and as there's stress towards producing more biomass, you're going to see more people evolve into those jobs, and there's going to be economic development there. So you'll have short-term price fluctuations, but I think it'll settle out economically.
The emphasis on biomass as a fuel, how does that impact on the warming in general? We're still emitting gas products. Why don't we talk, and I haven't heard a word today about alternative energy such as nuclear energy, which doesn't have that problem. Where does that fit in?
Nuclear energy there's a few issues with nuclear energy in terms, and you're right, in terms of providing for base load, so base energy needs, large centralized systems, nuclear does work most of the time more expensively than we think every time. The issue here is how do you build a flexible system? And I think there are waste products and issues with every source of energy. I don't care if you're talking about solar panels, wind turbines, nuclear, fossil fuels, whatever. Every single source has environmental impacts, and you can't deny that. The question is, how do we make a system that's flexible enough that we can get in place quick enough that can replace some of the more harmful sources, some of the more pressing problems like fossil fuels and carbon. Nuclear is a big part of that. However, when you get down to the local level, right? When you're trying to build a flexible system that will react to changes in economic factors, macroeconomic factors, when you look at the political and financial difficulty of building nuclear, it's clear that that source alone will not solve the problem. You would have to build a transmission and distribution system for electrical energy, right, to serve heating needs. And that's not the most efficient way to heat a home. Generating electricity, our demand fluctuates during the day. Nuclear reactors have to run at a set point. So when you're comparing biomass to nuclear, and I think the type of biomass that Steve's talking about is stuff that can be throttled up and down, small, decentralized. You have to use these two in tandem. And you can't really say one or the other is better. It's just they're used for very different things.
But I agree with you that peaks occur, but in any of those systems, there's a base load, and it could be supplied by nuclear
For electricity demand.
for electricity.
Hydro service the same function, and I agree with you that that's the situation we're in right now.
Another point I would wonder about, is it going to be any easier to be able to create a greenfields plant that services 30,000 people because of NIMBY? Any easier than an $800 million nuclear plant? I doubt it.
Are you serious?
I am absolutely serious.
Because
Look
I
at the
think
fire-
you'll find,
look at the fire situation.
I think you'll find that you will have opposition no matter what you build, no matter where you build it. But there are some unique challenges that come with doing very large-scale projects like nuclear that aren't there when you have sources that provide economic benefit to the area in which they're being constructed.
Are you suggesting that nuclear plant wouldn't provide a local economic benefit?
What I'm saying is, if I'm using energy here,
Yes.
the nuclear plant that's 100 miles, 200 miles up on the Bruce Peninsula down the road, it means I'm paying my money way down the road somewhere. Uranium money goes to Saskatchewan. Fossil fuels is the same thing. I think you will find that in general, smaller decentralized plants are going to have more support in the local community because some of the benefits stay there, number one. Number two, I think you'll find that when energy production is pushed down to the local level, we end up with energy sources that people are comfortable having around that are least harmful, okay? And I think while there are challenges with no matter what energy source you use, ask the government of Ontario, is it harder to build a brand new nuclear plant, or is it harder to build wind farms and solar farms?
You have to ask the question, is it harder to build a number of those plants, the equivalent power production of a nuclear plant? Which is the more difficult? None of those are easy. Witness the difficulties with wind power. Witness the difficulties with the fire has had and is having. Witness establishing a sanitary landfill site somewhere.
All of this stuff is getting tougher to do, which is why you need smaller, decentralized
I
sources
don't
that
think
people
that's the
are
answer. I think that would change the Environmental Assessment Act. It really is doubtful whether that contributed anything to the economy in the last 25 years. In my opinion.
We've got two other questions. Please go ahead.
You were first, I think. I would just like to point out about Lafarge, we should make a clear distinction at what phase of Lafarge switching to alternate fuel we're talking about. When they tried to burn tires, there was big opposition, and that was shut down thanks to the Environmental Act. When the environmental assessment was done, later in the game, it was shut down. When Lafarge tries to burn biomass, it has support of the community very much. There's no problem. People accept that. That's my reading of
Is it not true that they have withdrawn their application for their license?
No, quite the contrary. They just had trial burns
Just had a trial.
2 weeks ago, very
And
successful.
they are being
They're going as
assessed.
farmers are happy, everybody's happy.
And in fact, the data that is emerged were obtained by a totally independent, arm's length consulting engineering company.
I'm not suggesting that there's anything wrong with it. All I'm saying
But you are
is that
suggesting-
the public reaction is what the problem is.
No?
I agree that the public reaction to anything that we do, if everybody's comfortable with the world that we currently have, when you try to change it, somebody somewhere is going to find a problem. What we are recognizing that there are all those issues, and we're trying to deal with it in a very open and transparent way.
And the other thing with nuclear that I think is important, you hit a key point. The environmental assessment process is difficult to get through when you're trying to build anything. Doesn't matter if it's nuclear, biomass, solar, wind, okay? Steve said the problem was political. It is and it isn't. There's a real policy gap here. And people can't figure out which direction we want to go. Because the question comes up, that the arguments, people are either for or against nuclear. They're either for or against wind. They're either for or against solar. What we have to realize is that silver buckshot idea has to be reflected in the policy, and governments have to get out of the way. You can't skip this environmental assessment process, but if it blocks every good idea, we're in trouble. And I don't think it has blocked every good idea. I think there are a lot of things that could be done to make people feel that it's less risky to invest money in something. If the criteria were clear, if the timelines were set, and they're working on that in our province and other locations, whenever you're building anything, that environmental assessment wild card comes out, and things are so political, it's too risky for people to really put their money in. You might invest $100 million and then get kicked out at the end of the day. And that's a real challenge. That's a political and policy challenge. And nuclear, biomass, renewables, doesn't matter. We've all got to face that challenge.
There was a comment at the back, or a question?
I would agree with a lot of what I've heard today. I would suggest that we are not only in denial about global warming consequences, but I think as a world economy, we're addicted to liquid fuel, and we're in denial about peak oil. And I don't think I heard the term used by anybody today. So
I didn't have enough room for slides.
can I ask for any comment that there would be on whether or not, how best to motivate the world, let alone our leaders, to get out of denial on global warming impacts and the likelihood, the time I can't say, of peak oil? Right ahead.
I think before I answer that, I'd like to draw your attention to an article that was in, I think, the Globe this morning. It deals with various multinationals flexing their muscles to get access to the Marcellus Shale in New York and Pennsylvania and so on. And in a sense, I don't think the general population is in denial per se. I think it's just the fact that it's so easy to get access to stuff. And everybody seems like, well, we found more.
Right.
So we don't need to do anything.
Yes.
Yeah.
Understanding there might be a couple of decades to scale up whatever the solution is.
Which is where I came back to on my last slide, saying, okay, let's say we make a decision today. Global warming, I think, is a given. So what's going to happen 20 years from now? So we make a decision today. Global warming is occurring, so that means that we'll have palm trees here in 20 years, let's say. I mean, what decision we make today will allow us to adapt to that new situation? And I don't think we have done enough discussion and then compound that with the fact that everybody wants to get oil out of the Arctic or some shale or whatever. So it's a geopolitical problem and a commercial problem.
It's a distribution problem as well.
Then
Go.
I have a comment about, there's a fellow named Robert Jensen, Jen, who writes about this, very smart guy, writes neat stuff, I think. And he says, of course, it's no fun to acknowledge collapse. It's no fun to think about it. It's certainly no fun to face it. Who wants to do that? And so, we all sort of pull back inside of ourselves. And I think what we have to do is just what we're doing here. We have to open our eyes, we have to talk about it, we have to admit our fears, we have to, if people really understood the situation, you would be angry and depressed. I'll tell you, I read this stuff every day, and I wake up in the morning and I worry about my kids, because it is way worse than anyone thinks it is. So what we have to do is we have to educate ourselves, we have to talk to each other, and we have to confront our fears, and we have to work together to figure out what we're going to do.
The liquid fuel issue is the same as the electricity issue. And I think Stephen's point, when he said that technology exists, whether it's whatever source you want, we have enough renewable and alternative energies to supply our demand. Period, full stop. How do you get it to the point where it's needed? Our systems, our legacy systems, they've been invested in with the idea that these systems are going to be around 100 years. It's so expensive to move. What's the bottleneck in Ontario for renewable energy? I tell you what, feed-in tariff contracts, oversubscribed, way oversubscribed. More demand, more people want to build renewable energy than the government ever thought. More people are willing to put their money into it. What's the bottleneck? It's our distribution and transmission system. It's redesigning a top-down system to one that can accept things from wide and distributed sources. And those are the challenges. This is not, you say it's a political challenge, it is, but it's also a technical one, especially when you start to talk about distribution and transportation of power sources to end users. And that's why breaking it down into some of the regional work that's going on across the street at the Institute for Energy and Environmental Policy, looking at how do you balance energy needs with energy supply locally. If you can break down the need to have these huge distribution systems, you get closer to a sustainable system long term. It's doable, but that's, I think, where a lot more focus has to go. People concentrate on the source, the source, the source. It's not the source, it's how you get it to where it's needed.
Excellent. We have about 4 minutes. Are there other questions? In fact, what I'd like to do is to just give you a heads up. We each have an opportunity to prepare a final remark. So is there, Maureen?
I have a question for Stephen Sottile. Do you have any information about the microfit program, that whether the government's going to be moving ahead with it, or we're seeing some change and move in that? And
The best people to talk to are the folks at Switch. They have their fingers on the pulse. We are receiving a ton of microfit applications. We're processing them quickly in our distribution territory. We operate the Kingston hydroelectricity system. And the city of Kingston is moving ahead with 10 microfit systems on city-owned rooftops. The RFP went out last week. I get the sense that they're certainly not going to pull it before that end date of November. I think that would be political suicide. So my advice to you is get your application in soon. Show that the demand's there. The more applications that are in the queue, the less likely it is they're going to move away from it, because the more evidence there is of support and desire to build these types of systems.
Steve, for those who may not know what the microfit system is, do you want to just put a 2-sentence?
Sure. Feed-in tariff is a system of procurement for energy whereby a fixed price that's geared towards making sure there's a reasonable rate of return is given to people who want to produce energy. It's paid for what you produce. So the feed-in tariff provides fixed prices over long-term contracts. That allows people who want to build energy generators from renewable sources, or any other source for that matter, to have the financial security they need to finance and build. Cool.
Thank you very much. We're going to just take final comments from the panel and then we'll close. We'll start with you, Burt.
I guess what I would say is that one of the encouraging things that I know about is that there is grassroots stuff happening. We're doing stuff, on the ground right now, not far from here, there's a whole community, a farming community, there's a tradition of sharing that type of information. So, we've talked a lot about sort of potential and big ideas, but actually on the small stuff, there is small stuff happening, what's happening right now.
Thank you, and I encourage you to go to the Burt Greenhouse's website. Andrew?
I'd like to continue on with that. I think what we've got here is a very interesting staged action within this region. We have the examples of Burt's greenhouses. We have the examples of the Lennox and the Tamworth switchgrass being moved into possible new schools for heating and so on. And that, I think, will begin to branch out. And then we've got the example, potential example of a really big industrial user that really wants to shift from coal. So we've got this hierarchy of applications, and I think as a community, most of us are supporting all of this because we know that whatever we do, it can act almost as a template for other communities. So by working together, we should be able to achieve something, hopefully in a very positive way.
Everybody is going to find something about this problem that is really interesting to them. Anybody from any discipline can find something in this question and in this problem that motivates them or makes them want to look further into something. I would encourage everybody in this room to pick something, talk to a bunch of people, pick a little area of it. Don't worry about the big picture. Do what you can and what you're interested in and what makes you happy with a mind to this stuff, and we'll get there. But if we don't have people who are passionate and happy in their work, we're not going to get there. So find it, figure it out, make something like this your career. There's plenty of opportunity out there for you.
Very nice. Yeah, I think small distributed generation really is flexible generation is the way to go. Microfit is a fabulous program. You should look into it. It's a way better investment than mortgage-backed securities, let me tell you. And it's the very least you must do because we have to get off our keisters and save civilization.
Dave, closing remarks.
Well, I'm very honored to be here. Thank you very much for everyone to be here. And I think it's wonderful to hear the diversity of opinions, and it's wonderful to see everyone here so interested in this subject, and I think that's the most important thing. I'm a fence sitter on a lot of these issues because I don't pretend to be an expert on any of it, and I really enjoy listening to everyone's differences of opinions. I was hoping Stephen was going to talk a little bit more about conservation because I think really conservation is a really key issue here, something that we can all do that will really help us. And I really genuinely do hope that we can switch to, I guess, locally sourced materials for our needs. I hope one day that we will be able to do that. Realistically, I think that the issues around economics of that sometimes will come into play in terms of keeping Canada competitive, and I think we've got to really keep a very clear idea, a clear vision on how we sit in a global economy, and be careful that we don't do anything, a knee-jerk reaction that will make us very uncompetitive. Thank you.
Thank you. Will you join me please in thanking our panel? They're multi-pass, so they have a little bit of a difference. Final announcements. First, if you have not signed this sheet, please do sign it and let us know that you were here. So I'll leave this right to the end by George. Also, if I could just, there are handouts, the slides for our speakers. If you didn't pick up the slides, please do pick one of those sets up too on the way out. I'd like to thank you all for coming. If you were on the video and you don't wish to be videotaped, just let me know. We put these up on the web so that others who are not present can benefit. I'd also like to thank our sponsor, Pella CFDC. Really appreciate your support. And I would say, those of you who can stay behind now, please know that we've got this room booked for up to another hour. We'll have have a very focused discussion with a smaller subset of those of you who want to talk about specific action that you as an individual or perhaps collaboratively we can take to make a difference and move things forward. Our next seminar will be on Wednesday, December 8th. We'll look at green entrepreneurship. Dr. Jane Webster will be part of that seminar. We look forward to seeing many of you there. Thank you all for coming.